Recording now. So, hi everyone, and welcome to another edition of our BI and Data webinar series brought to you by Robert Walters. Today, we're joined by Amro Safadi,
Signatures in the hairdressers
over at Auden. He's going to be speaking about how to ensure a positive data science impact in your organisation. Now, before I pass you over to Amro, as always, just a bit about me. Can I have the next slide, Amro? Thanks. So, you probably know me already, but my name is Chris Ingman. I'm Senior Recruitment Consultant at Robert Walters, specialising in business intelligence, data and analytics. I've done so for over 5 years now, and happy to say the market's really picked up. We're getting really busy. So if you are in a situation where you are looking for a new role, feel free to get in touch. My email and telephone numbers at the bottom of this slide. And also, if you're in a position where you're looking to expand your team, again, feel free to get in touch. I'm more than happy to give a bit of information about the market. Just a short intro from me today. That's it. So I'll pass you over to Amro after now. So as always, if you can just keep your the microphone and video off, just to make things run a bit smoother. Today's session will be recorded, so it'll be on our YouTube channel. You can check it out after. I appreciate the weather is really nice today, and we'll be doing a Q&A at the end as well. So any question you have, just put it in the chat box. I'll man it and obviously pass them over to Amro at the end. And that's it from me. So Amro, if you'd like to take it away.
Yeah. Can you see my slides?
Yeah, I can see them.
Okay, cool. Hi everyone, it's Amro Safadi here, Head of Data Science for Auden. Thanks for Chris arranging this opportunity for me to speak to you about my experience leading data science units with different organizations. I'm going to focus the talk today on ensuring the positive impact data science can have on organizations, mainly talking about how we drive growth and save costs using data science. I'm going to keep it light today. Weather is good, so I'm going to keep it short so you could finish this and enjoy the weather outside. But yeah, hopefully you find it useful and interesting. So, so you are presented with opportunity. You are told, right, data science is the fashion, is the buzzword. The organization now wants to invest in data science and start hiring data scientists. Let's be clear, a lot of senior management and board might, in the past hear the word data science and machine learning and things. Great, this is a buzzword. Is it going to actually give me anything? But that's where we need to come in and ensure that data science is delivering value. So the battle, or what we need to really show that data science is not just a buzzword. It can have a positive commercial impact on the organization you work for. So I think it'd be useful just to recap quickly, what is data science then? So data science is really that intersection between the computer science IT skills that people have, the domain business knowledge that is necessary for any data science to acquire to achieve good results, math and statistics, because data science is not pure IT, pure code. It requires you to have a background around how to measure models and how to know accuracy using statistic and math, etc. And acquiring all those different skills really brings data science to the front, and that's what can really ensure. For example, when you are recruiting, you can't always find the unicorn, as we call it, somebody who's got all the skills, but you know what you're looking for. So if you are looking for a machine learning, then the focus on math and computer science. But if you want a domain knowledge, then you really data scientist is the word. The day in the life of data scientists does not mean that they are always just building models. There are a lot of things that data science needs to do to enable the work that they do. So there's a lot around collecting data, managing the data, exploring the data, preparing and aggregating data, and doing a lot of analytics until we find an appropriate input into our models that we're going to build. And finally, there is always the optimization and testing that need to be in place. A lot of these things describe the daily activity of a data scientist, and I recommend looking at this diagram. Right, so you are a data scientist, or you are looking to hire a data scientist, and you decided to press the start button, and here you go. We have data scientist team. What to do now? So it's very, very important. The first thing to do is actually pause and consider. Either being an organization leader or being a head of data science or a data scientist itself, it's really important to just, before you embark on any work, is to actually think, do we actually need data science? Is machine learning and data science the tool that is going to answer the business question for this specific issue? A lot of the time I see people thinking, not really able to match what data science can do with the problem that they have. So it's always important to pause and consider. And we'll talk about details how to do that. The second most important thing to do is, once you agree, you thought data science is good for me and I need it, then try to start identifying the specific opportunities within the organization. So what are those questions and problems that data science and machine learning can come and solve? And not only identify them, we need to prioritize them and understand how do they align to the business strategy overall. And here we go, we understand the business strategy. So without actually going and investing time in understanding the business strategy, understanding the business objectives for the few years for the future, it's really hard to actually build a successful data science unit and let data science have a positive impact on the organization, because you might be working on something that is really at the bottom of the priority list. And even if you achieved it successfully, it might not make a big difference to the organization. And you might understand the business strategy, understand the objective and the priorities, and then aim for the top one and go and start building your models and machine learning activity to help the organization predict or forecast and give this positive impact. But really, a lot of the time we see that there is other things to consider, like the resources and the infrastructure of the organization might have limitation on. If the organization have a very limited number of data engineers or very outdated servers or cloud systems, etc., then that needs to be considered. It might make you move from the top priority to the second one, but at least you won't build models and find out that you can deploy them and use them in operations. So it's very important to understand what limitations that any organization might have. And after you do all of this, revisit the opportunities and make sure that after you consider all these dimensions, that you have your opportunities prioritized so you could present them, share with the stakeholders, and provide the vision on where data science and machine learning can come and contribute. And here we go, we prioritize them and we create our roadmap. It's basically the steps that I do every time I really work for a new organization, a new company. I ensure that I understand what they're trying to do. Is there any limitation in the technology, on the resources? Prioritize the opportunities and present them in a roadmap for the organization. Okay, so those are the big headlines. So let's talk in details. What are the actual questions we should ask really to enlighten ourselves? What is the business problem or challenge being addressed? So now we identified the opportunity. Now let's define it properly and understand exactly what is the challenge. Are we trying to predict the best application, the customers to churn, or are we trying to predict what credit application we need to accept and reject? Just define the problem and agree with the stakeholder on that definition. Okay, and then what is the hypothesis on how AI will help? So are we all on the same page? some people might think AI can come and implement magic and solve all the problems. We need to ensure that everyone understands how AI can come and help. Maybe predicting scores that can enhance that decisioning. That's all what can the AI do in that specific problem. And managing expectation here is really important. Okay, and then am I starting this from scratch? Has this problem, and most of the time, every problem in organization faced has been addressed before. So is there any existing approach that the organization used before to tackle this issue? Have we tried to, for example, use normal knowledge rules or experiences from past employees to actually improve the decisioning around this issue? Or was there any actually existing machine learning algorithm or a model that was in place that trying to solve this problem but failed? It's very important that you address this issue and consider if there was any different method that's been applied in the past. First, so you learn from what happened and you don't have to do it again. And then for the comparison in the future to show where the science and model and machine learning model can come and help and improve. So again, for us to be able to do that, you need not to ask only if there was an existing approach to solve the current opportunity, but what is the actual achievement of that existing approach? Has it failed completely? Has it partially been applied and succeeded in just few aspects of that issue? So we really need to measure the performance of the existing approach to be able to compare it to whatever data science work we are embarking to do. And would be great if we can then agree on where are those aspects, where are those opportunities that we can improve and work on. This is honing down really on the actual benefit and trying to exactly highlight to the business where your models can come and make a difference. And then once we agree on all these things, we can move to defining what will be predicted and the means of consumption. So it's great that you say, I'm going to build a model to improve the supply chain management, but then that's not enough, in my opinion, to start any work. It needs to be defined properly. What is the prediction score going to be used for? How is it going to be integrated in the operations? Is it going to be relied on solely, or is it part of other factors that needs to be considered? It's very important that we understand the complexity of any work that we are doing. So it might be that this opportunity is great, but the number of data sources or data set that needed to come in, used as an input for the model or to enrich any data source we're using is unrealistic. And in that case, it might you'll end up using part of the data that is available, and the output will not be as good. So it's not fair on obviously on the data science, on the model to be judged if the input is not available. So it's very important to ensure that all the data that we need to achieve success is available. And not only estimating the complexity of the input and the data, but we need to estimate the complexity of the predictive model itself. In some cases, really, the model is so complicated. Although on your machine or on the local server, it can produce a score, but it might not only produce the score that achieved the uplift, maybe after 3 or 4 hours of running. If this question or problem is live, is online, is interacting with customers, no one is going to wait all that time to reach the decision or to reach the score. So the model might be very successful on paper or when you actually build on your machine, but you need to ensure that the model is not too complicated. For example, some models are an ensemble of different models, and in that case, they take more time to run. And if that's the case, you need to ensure that the problem you are trying to achieve does not require seconds or milliseconds of speed. Otherwise, it will not be appropriate. It's very important to understand how your models are going to be integrated into the organization systems. What are those technical, if you like, obstacles that you need to overcome? Are we deploying locally? Are we deploying over an API? Are the systems open, for example, to API calls, etc.? All these challenges I faced before in the past, and I know they are very important, and would be great if we can agree and define them before we actually start any work. And again, as I mentioned before, we need to agree that score that come out of your model, how is it going to be used? What insight is going to be derived from the score? You might be building the model thinking my score is only giving one of, kind of insight into the problem, shouldn't be used solely making decision. And that should be clear to any stakeholder or any project manager that is responsible for this. Okay, well, let's go back to the first point when we said, or second point when we said, let's identify opportunities. A lot of people say, okay, I know I need to identify the opportunities, but I don't know how to go about this. How can I go to the business, talk to the stakeholders and find out from those workshops, what are those opportunities that are needed for the business? Most of the time, the business don't have these opportunities listed for you. It would be great if they already thought about that, but sometimes it's the scientist's job to actually go and explore and find out those opportunities within the business where data science might come in and make a difference. So a good start is always to ask, okay, where is the data-driven profit drivers within the organization strategy? So think about opportunities that drive profit and positive commercial impact, and that relies on data to achieve so. And then what are the specific decisions that by taking we influence each of these drivers? So we might say, okay, so data-driven profit drivers are accepting or rejecting credit application. Great. So what are the specific decisions? So maybe the decision is predicting how many people are going to default on a loan. We might be the decision on how many people are going to fall in arrears. Maybe the decision on how much the margin. How can we predict the profit margin for every customer, or a decision about customer churn? So specify those decisions that contribute to those profit drivers. And then ask the question about what data could be available within the organization or from other third parties that may help optimize that decision. Do we have all the data? Is there a data that organization is looking to acquire from somewhere else? Usually that will give you a clue where the organization needs to invest and improve their decisioning. So now we talked about the questions you need to ask, but how should you ask these questions? First, approach the key stakeholders. So, for example, if you are tackling issues within supply chain management, obviously talk to the teams and the head of teams that are responsible for supply chain management. If you are tackling problems within financial services, talk to the director of financial services and the head of lending, etc. Ask about the data that the company store and use, and what other data that could be available to acquire. And then obviously, once you've answered all those questions and you already start building your models, and don't only build one model, obviously, use different technology and methodologies and compare models if possible. That will give you the best outcome, and you could highlight the uplift and the difference between each of them. Make sure that you are validating the results. So always run blind tests and hold out to be able to ensure that the model are not overfitting, etc. And then write down the expected uplift. And once agreed within the organization, deploy and maybe test it on live customers, only a segment of them. I've got someone called Martin Squires keep trying to take controls over my presentation.
Oh, sorry, that I was just having a look at the participants list. I do apologise.
Okay, no problem.
I pressed the wrong button in that case. I was just looking at the participants list. Sorry.
Yeah, no, sir. It's the third time, so I had to mention it.
Oh no, you did right. I've been merely pressing the wrong button. I do apologise.
That's okay. Every time you mention it, that presentation goes away, so I have to go back to it. That's fine. Right. So let's talk about now the technology that might enable us to do all what we said what we can do. So what are those aspects or features that the technology that uses will enable you to achieve success in data science? From my obviously humble experience, there are many tools on the market. People like open source. Python obviously is the data science tool that everyone knows talk about. We have other platforms such as SAS that provide you with a drag and drop way of creating models, and many others on the market. But from my experience, we need a technology that allow you to spin out model very quickly, so speed. You need a technology that is reliable, so you could knows that the model that you've created is a robust model. I tend to avoid black boxes. So I mean, a lot of people talk about neural network as a black box. It's not always the case, only if it's very complicated and can be explained. But usually, and especially in finance, you need to avoid anything that you can't really define and explain in a plain English. And obviously, technology that just create models might be good on its own, but when it comes to deploying these models and put them in operations, I would look for a technology that give you that support around deployment. How can we take that model we created from that platform or from wherever and actually deploy it and put it in operations? And finally, a technology should provide you with a monitoring support. So now my model is deployed, is in operation. That doesn't mean it's the end of the story, obviously. Models can deteriorate, performance can deteriorate, and data drift can happen. The organization might move to target different segments, different demographics, and that will obviously have a great impact on the performance of the model. So any platform or any technology that give you these tools to monitor the model easily, then that obviously is a very important factor to consider. And most of the time, the models are not just created by one data scientist. There is a team of data scientists, and it would be great if this technology allows you a degree of collaboration between the different data scientists to share models, look into each other models, and be able to share ideas over the platforms. And finally, I really like cloud-based because most of the organization going towards that direction. So if the platform or the data science or the machine learning platform allow you to directly connect to our data sources, including cloud-based data sources such as GCP or AWS, then that's a big plus point. Those are, in summary, really the factors that I consider. So, for example, in my current job and in the previous one, sensing that the organization that I work with did not want to go on a recruitment drive and hire a lot of data scientists that write code from the scratch. They wanted a tool that allows, as I said, the speed of creating models. We went towards the auto machine learning sort of a dimension. And we use SAS, but we use mainly as well DataRobot. It's a great technology and great platform, and for me it ticks all the boxes on the left. So yeah, it's what you look for really is end-to-end data-to-value platform, a platform that just not really focusing on one bit. It will make life much easier if you are using the same platform for all these activities, from manipulating data into feature engineering, model creation, deployment, and monitoring until you reach reach your value or added value to the organization. Again, the cloud-based, different technology. For example, in the case of DataRobot, they have all the open sources algorithm in R, Python, TensorFlow, etc. So for us, that was a good match. But obviously, one of the exercises that any head of data scientists need to do is try to match the need of the organization and the resources available with what platforms available on the market and choose best fit in that case. Right. Once you as we mentioned, once you deploy your model, it doesn't mean the end of the work. The end of the work. You always need to monitor this model, monitor the deliver. Is it delivering what is being expected? Is the organization getting the added value? If not, why? And is there anything we could do about it? All the models need to be, in my experience, need to be refreshed and retrained at least every 6 months to ensure that there is no data drift or accuracy drift that happened over that time. So yeah, deploying a model is not the end of the road here. Okay, so all that nice and rosy, but it's not usually that straightforward. As you all know, there are challenges, and I kind of faced a lot of them during my years working with data science and machine learning. So I mentioned a few of them that are always kind of highlighted. I should say from my experience, one thing that I always find really useful for data scientists, if they found who is the if you like, the equivalent of a chief data officer in the organization. It's a role that I really support, and I wish if every organization have a representative on the board for data. Usually a chief data officer would really be great for that. But I think many organizations at the moment, they don't have this person on the board. This task is either given to the CTO or sometimes to the CFO, and obviously that's not, data is not their main focus, so it comes as a second priority. But the data scientists always need someone on the board representing their interest and representing what they're trying to do, and hence some of these challenges will be solved very quickly if we have someone like that on the board. But let me mention some of those challenges. We touched on that before. Managing expectation. Again, some people may have a perception about what AI or machine learning can do for them, and that might not be realistic. It might not be realistic what they're expecting even the prediction accuracy to be. Obviously, as we know, no model is right, but models are better than others. So you can't achieve 100% accuracy. That's impossible. So that needs to be obviously explained and communicated to any decision maker within the organization. A lot of the time you find out that you've got the tools what you need, you can on the paper, you've designed your model, you can make a positive impact, but then when you try to push those that model, that basically propagated change into the organization, it's the human nature that you find out a lot of resistance, especially if you're doing that for the first time. A lot of people who don't know about data science or machine learning will be skeptical about what you're doing. Maybe it's not, or maybe that's not, that's going to affect my work, it's going to affect my job, it's going to waste my time. So obviously you need to be able to handle fear of change, be able to approach people and explain how is that going to help them, how is it going to make their life better and easier by supporting this change. And obviously if you can get, again, the support from the board, then usually this is much easier. Integration. So again, we touched on that point before, but your models are not going to be isolated from the business. They're going to be very important to integrate with the business in order to be in operations. So any business system that currently use either to interact with clients or to manage supply chain, say, or to manage collections in the case of financial services, etc., is very important that you understand the technology that is currently used and how can you integrate the models that you created with the existing technology. In my case, we found out a lot of the time that we can achieve millions of pounds of added value and benefit, but what we have to do is actually scrap a technology that is currently in use and bring an updated technology, and that obviously carries a lot of cost. So that should be added to the equation that you have when you present your return on investment, or what kind of cost and positive value that data science can bring to the organization. Again, that's something we can't avoid in organizations. Some people might have a different mentality or a different agenda. Sometimes it's very important to understand motivations within the teams and what will allow you to succeed. Are there people who just don't believe in what you're doing and they believe in something different? So it's important to try to solve these issues. And obviously how to solve them, that's a different sort of a talk altogether, but it's important to identify them and know about them. Otherwise you're going to build something and find out a lot of people putting obstacles in your way, so to achieve the good result that you can achieve. So what I want to kind of conclude with is like a practical example, just to give you a sense of something that we kind of did in the past. So what are the opportunities we identified? So for example, we can improve the accuracy of our decisioning, accepting and rejecting new credit applications. So if you are working for financial services, obviously they get either application to get a loan or to get a credit. And most of the time, this decision based on credit scores or credit our scorecards that built in the past using trial and errors and experience. Can we get machine learning to come in and provide an uplift or improvement on the accuracy of the current decisioning? So how do we achieve that? We define it by let's accept more profitable applicants. Are we actually rejecting people that could be profitable for the organization? And are we actually preventing people who might lose us money, end up in defaulting or being written off that we currently accept? Can the machine learning come in and improve this decisioning around those two aspects? Another example, assessing the risk profile for people who are currently in arrears. So, for example, if you can create risk categories with high risk, medium risk, low risk. A lot of the organizations treat people who are in arrears or not on top of their payments as the same, but that's not always the case. Some people are higher risk than others, and that will shape a lot of the strategies or the approaches that organizations take to deal with those customers. So, okay, you identified the opportunity. Those are a couple of examples. How can we calculate the benefit or the return of investment? So obviously, it's very important that you build your model on existing data. And we said you test it on a blind data test part of this data, the data that is representative of all the segmentation, all the demographics in your data. Make sure that your model is obviously achieving high accuracy, as you can see from this graph, from the confusion matrix graph, and then do some simple calculation like that, obviously with the help of the domain knowledge and people who are already knows the business. So, for example, in the case of improving the accuracy of decisioning around credit application. So how much reduction in defaults, people who are defaulting, we can have? So can we save 10,000 of currently customers who are defaulting in the future by not accepting them? And then multiply that by the cost of default. So how much each of them actually costing the company? And then add on top of that the cost of communication. And so you have to put for every customer to be able to collect the money back. Take out of that is the debt selling. So once you can collect, you can sell your debt. So there is money can come back. So this is just a simple example just to give you an idea how can you, after you create a model, kind of create this value that you could present and estimate to the senior manager or the decision makers around how much money this contribute or this model can contribute to the company. Obviously, a lot of factors need to be considered, and always good to talk to a lot of people. So there might be things that you're not aware of that comes into play here. But actually engaging in those conversations really is very important for the data scientists to raise the profile of their work. And that's conclude my talk. Yeah, it's just half an hour, so I hope you enjoyed it, and I'm happy to take any questions.
Yeah, thanks, Amro. That's great. Thanks. Yeah, like Amro said, if anyone has any questions, feel free to drop it in the Q&A chat box, and I'll read them out. Again, me and Amro were joking at the start, saying every time we seem to schedule a webinar, it's always really good weather. We actually cancelled the last one and rescheduled today because it's the hottest day of the year. I think we've got the same thing today, so maybe we should, Amro, maybe we should plan some more.
Sure, why not?
Yeah. Any questions, guys, though? Doesn't seem to be. So should we just leave it there for now? Like I say, obviously everyone, you know, any question you might have, feel free to contact Amro direct. It's not a problem. But otherwise, look, Amro, I want to say a big thank you. Obviously, again, I know the web has been really good, but I really appreciate your time. And obviously, you know, this can be viewed on YouTube for anyone who wants to revisit it anytime. Just at the next slide, Amro, just for the next webinar session. Yeah, here we go. So half the presses, we're going to be joined by George Mulroy, Head of Data at Twinkle Educational Publishing. He'll be joining us on the 28th of August to Friday at 12:30. He'll be speaking about how to move towards a self-service single version of the truth data culture. Give us a bit of a walk through what he's done since joining Twinkle. And again, just final slide, Amro, again from me. So obviously, you know, if you are looking for work again, if you're looking for a new role or looking to expand the team, here are my details. Feel free to get in touch. Alternatively, if you're looking to speak, if you'd be interested in doing a talk, or alternatively, if it's a topic you'd like to see covered, feel free to get in touch. I'm more than happy to hear. But otherwise, again, big thank you to Amro. Thanks for everyone for joining, and we'll see you next time.
See you later. Thank you.
Thanks.